these notes are on x-intercepts. So the work that we've been doing with factoring comes back because the factors of a quadratic, when I factor them into a multiplication problem, I end up actually with a place where I can find the x-intercepts that way. So the first thing we need to know, just a reminder, x-intercepts are where the your function crosses the x-axis. Remember that when I cross the x-axis, my y equals 0. So if I have two numbers, this is called the zero product property. If I have two numbers that multiply, when I multiply them, they equal 0, it must be the case that either a is 0 or b is 0. 0 times b is 0. A times 0 is 0. So if I'm thinking in my head of two numbers and I say they multiply to be 0, you would say, well, one of them has to be 0. So now if I look at this example, this is the zero product property. Here's my A, and here's my B. So either x minus 4 equals 0 or x plus 6 equals 0. That's what this said. It said either my first number equaled 0, my first number equals 0, or the second number I'm thinking about, the second number equals 0. So now in order to get the x-intercepts, I need to solve for x. So I add 4 to both sides, and I subtract 6 on both sides. So my x, so actually I'm not going to do the x-intercepts part. This is just the zero product property. Sorry about that. So now let's actually do some problems where I'm finding the x-intercepts. So remember, x-intercepts means that the y equals 0, or another way is to say the f of x equals 0. So in the first example, I'm going to rewrite this to be 0 equals x minus 3 and x plus 8. And remember, if I'm thinking of two numbers, here's the first, here's the second, and I tell you that when I multiply them, they equal 0, it must be the case that my first number, x minus 3, equals 0, or my second number, x plus 8, equals 0, which means either x equals 3 or x equals negative 8, which means my x-intercepts are 3, comma, remember x-intercept, y is 0, so it's the point x, comma, y, 3, comma, y, or negative 8, comma, 0. In my second example, I have to actually factor. They're not, they didn't write it in the factored form. So I need to first go through my, in this case, A is not 1. And so I need to check if I can factor something out in common. And I can. Both of these numbers are divisible by 4 and by x. 4x times what gives me 4x squared? X. 4x times what gives me negative 8x minus 2. And because we're finding the x-intercepts, they equal 0. So again, either my first number or my second number must be 0 in order for them multiplied to equal 0. So either my first number equals 0 or my second number equals 0. Well, dividing by 4, I get x equals 0. Or adding 2, I get x equals 2, which means my x-intercepts are 0, comma 0, or 2, comma 0. Now, the x-intercepts can actually give me some other pieces of information. The x-intercepts can also give me the information about where the vertex is. And if you remember, parabolas are symmetric, which means that if I have a parabola, so first let's find the x-intercepts actually. So 0 equals x minus 9 times x plus 7. Again, either my first number equals 0, or my second number equals 0, which means my x is either 9 or -7, which means my x-intercepts are either 9, 0 or -7, 0. So just a quick sketch here on the coordinate plane. There's one x-intercept and there's the other. This is at +9, this is at -7. So because parallels have a line of symmetry, it follows that the line of symmetry is halfway between -7 and +9. So I have to go halfway between. Now there are a lot of ways to do this. One way is counting using a number line, in which case I go 7 this way. And when I go 7 from here, I land on 2. So I'm now at 0 and 2. And what's halfway between 0 and 2? 1. Now, the other way to do this is to recognize that halfway between is to take the average. So the average would be -7 plus 9 divided by 2, which is 2 divided by 2, which is 1. So now I have my line of symmetry. Remember, though, that the vertex lies on the line of symmetry. So I right now, right away, know that my vertex has an x value of 1. So I need to find the y value. Well, if I know the x value, I can plug it in to find the y. So I've got y equals 1 minus 9 quantity squared times 1 plus 7 quantity squared. So that's going to be a -8 times a +8, which is -64. Let's look at a second example of this. So again, I'm looking at my x-intercepts. So here I need to use the zero product property again, because x-intercepts means y is 0. I now have 3 options. Let's see what these say. I have the number 3 must equal 0, or x minus 8 must equal 0, or x minus 13 must equal 0. Well, 3 doesn't equal 0. It's not true, so I don't get an x value from that. But I can solve for x, and x minus 8 equals 0. That's where x equals 8, or x equals +13. So again, if I draw a quick sketch here, if I have x equals 8 and x equals 13, I'm looking for the line of symmetry. Again, I can count, but I'm not that interested in counting. Counting takes some amount of time. And in this case, counting actually isn't going to be as helpful as we would like, because when I find the average of 8 and 13, I end up with 21/2, which is also 10.5. So that's not as helpful as it wouldn't be as helpful to draw the picture in this case, because it doesn't lie on a whole number or an integer. It lies on a rational number. So now I know that my vertex has an x value of 21/2, or 10.5. We'll write it both ways. And so now I can, draw in this line of symmetry x equals 21/2. Remember, kind of already did this, but remember the line of symmetry gives you the x coordinate of the vertex. So now I need to go back and I can plug into this equation my x coordinate for my vertex. So I have 3. I'm going to use the 10.5 in this case because it's going to be easier in this case to work with decimals. So I have 3 times 2.5 times -2.5. And then if I take out my calculator and multiply -2.5 times +2.5 times 3, I end up with -18.75, which means my vertex is at 10.5, comma, -18.75. If I want to rewrite my 18 over 18.75 as a fraction, it's negative 18 plus 3/4, etc., etc. You know, depending upon what your teacher wants, you'll have to talk to them about the exact process. Well, actually, let me do it a second way over here. So if I use my fraction, I'd have 3 times 21 over 2 minus 8 times 21 over 2 minus 13. I can rewrite my minus 8 as negative 16 over 2. I can rewrite my negative 13 as negative 26 over 2, which is going to give me negative 5 over 2, positive 5 over 2 times negative 5 over 2, which is going to give me 3 times 5 times negative 5, negative 75 over 4. So again, depending upon whether or not your teacher wants your answers in decimal or fractions, or if they don't care, you know, you either plug in the decimal or you can plug in the fraction.